Okay, today we're going to be going over 8.3, which is on inverse trig functions. Our learning target is I can find the inverse trig function and use them to solve for a missing angle. Our pathway connection is to health science. So radiologists use the technology from trigonometry and medical imaging to calculate a position, size, and shape of organs and tissues using x-rays, ultrasounds, and CAT scans. Okay, so even though maybe you don't think about it, health sciences are using trig in all of those machines that they do. Luckily, the machines do most of the math for us, so we don't have to, but there is still math involved. Okay, last time we learned new operations called trig functions. There exist 6 of these styles of functions, but we only learned about 3 of them. Okay, and these are called sine, cosine, and tangent. Right? Now remember, we applied trig functions to angles. To use some old vocabulary, the domain of the trig function must be angle measures. And domain is the input values. So our input is angles. And then, so if we look at the expression sine of x, x must represent an angle measure, like theta does below. So theta here is an angle measure, and x in this sine of x is also an angle measure. Now the answers that we got last time, or the range, are the ratios of the sides. So we put in an angle and we got out a ratio. Okay? In other words, we start with an angle, perform the trig function, and the answer is a ratio between the sides of the triangle. That's what we did last time. Now today we're going to learn about the opposite operation. These are called inverse trig functions because they do the trig functions in reverse. In other words, they undo or cancel out a trig function. All of our other operations have an opposite, and these ones do too. Okay? Just like multiplication's inverse or opposite is division, and addition's inverse or opposite is subtraction. Okay? Now we have 2 notations for trig functions. The first one is a little -1 in the exponent of the trig function. It looks like this, the inverse sine of x. This means the inverse sine of x. And then the second one is using the letters ARC or arc in front of the trig function, like this. So that's arc sine, which also means the inverse sine of x, but we say the arc sine of x. Okay, both of these are totally acceptable. The one that our calculator is going to use is this first one, the inverse sine of x. I will probably say arc sine of x just because it flows a little smoother, but this is probably the more popular notation. Okay, the important thing to remember is in this case, x does not represent an angle anymore. Since this is the opposite operation, the domain and the range have switched places. So now the x represents the ratio between the sides, and the answers represent the angles. Okay, so we've switched because we're doing the inverse. Before we had used x's as angles and we got ratios, and now we're going to put in ratios and get an angle out of it. Okay, so we can use our calculator to identify each one of these and find the missing value. So on our calculator, we have our sine, cosine, and tangent buttons that we used before. If you push the second button in the top left corner and then click sine, cosine, or tangent, you will end up with an inverse sign that looks just like this. Then it'll have an open parenthesis. So push second, sine, and then type in 0.125. Then if you push enter, you should get your answer being 7.2. Okay, and that is an angle, so it's 7.2 degrees. Okay, so this would represent our angle, and this would represent our ratio. Now, if we put the inverse tangent of 5/3 in our calculator, we are going to end up with 59 degrees. And again, this is an angle, and this is a ratio. And then if we do arc cosine, remember there's two notations, so even though it says arc cosine, I'm still going to put second cosine and then 1/2. It gives me 60 as my answer, so it's 60 degrees. And again, that's our angle, and this is our ratio. Okay, solving for an angle in a right triangle. We can set up the same kinds of trig equations we did last time to solve for a missing side. But now we just have to get theta all by itself. So let's investigate how to do this. Okay, so for this triangle right here, they've already written my trig equation. It's the cosine of theta is equal to 9/12. I want to know how I'm going to get theta all by itself. Well, if I am looking at an equation like 5x equals 12, and I'm trying to get x all by itself, what I'm going to do is divide by 5 on both sides, because that's going to cancel the 5's over on the left-hand side. The reason I divide in this case is because 5 is being multiplied by x. We have 5 times x. So I do the inverse, which is division. Okay. Now applying that to this question here, if cosine of theta is my operation, and I'm trying to do the inverse of that, we talked about the inverse of cosine being the inverse of cosine or arc cosine. I have to do that to both sides here. So what this looks like is I'm going to wrap everything on the left hand of my equation in parentheses, and I'm going to have the inverse cosine go around that. And remember, what I do to the left side, I also have to do to the right side. So everything's going to get wrapped on the right side. And I'll also have the inverse cosine over here. I'm just going to rewrite this so we see it a little clearer. I have the inverse cosine of theta. That is equal to the inverse cosine of 9/12. I just rewrote that. Okay. And now I've got the inverse cosine of cosine. Those are inverses of each other, so they're going to cancel each other out. And that's going to leave me with theta is equal to the inverse cosine of 9/12. And now this is just a number that I can put in my calculator and I can solve for theta. This question doesn't tell us to solve for theta, so I'm just going to leave it as is. But on the next couple examples, it is going to ask us for those. So to summarize, we take the inverse trig function of each side of the equation to cancel out the regular trig function, so the angle is by itself and we are solved. Okay? So let's practice this. So solve for x. So I'm going to follow a lot of the same steps as before. Okay? I'm going to first, step 1, identify my angle. It's this down here. Step 2, I'm going to label my sides. My hypotenuse is always straight across from the 90-degree angle. My adjacent is always touching my angle, and my opposite is what's left. Now, step 3, identify which trig function I need. I have my hypotenuse and my opposite. So that is going to be a sine opposite over hypotenuse. Now, step 4, I need to set up my equation. So I've got the sine of my angle, which in this case, my angle is x. So the sine of x is equal to, now my trig fraction, my opposite over my hypotenuse. So that's equal to 39/74. Okay, now I need to get x all by itself, so I need to do the inverse of sine to both sides. So I'm going to end up with the inverse sine of x is equal to the inverse sine of 39/74. Now the inverse sine of x are going to cancel each other, and I'm going to be left with x is equal to the inverse sine of 39 over 74. This is something I can plug into my calculator, and when I do, I get x is equal to 31.8 as my angle. Okay, example E, same steps. Step 1, identify my angle. Step 2, label my sides. Adjacent's always touching, and opposite is what's left. Now step 3, step 3, identify which trig function I need. I'm using my opposite and my adjacent, which happens to be tangent. Step 4, set up my equation. I'm using tangent, so I'll start with tangent of my angle, which is x in this case, is equal to, now my fraction, my opposite over my adjacent, 6.7 over 4.9. Okay, now, in the past two examples, we've written out that the inverse sine of sine, and in the last one we did inverse cosine of cosine. That's what is happening every time. However, I can just skip writing that down if I know that to get x all by itself, I have to do the inverse of this. So I can just jump directly to x is equal to the inverse tangent of 6.7 over 4.9. And then I can just put this into my calculator, and I'll end up with x is equal to 53.8. Okay, so that's all today's lesson is. It's you set up your trig equation just like before, but now we do the inverse trig function of our ratio. Okay, so this should fly by very quickly. We are going to do examples F and G as partner practice. When you get those finished, come up and get a stamp for credit. And then we do have a very short Delta Math online.